Part 1. Motion is relative. Back all the way in Galileo's day in the 1600s, people were questioning whether the Earth was revolving around the sun or the sun revolving around the Earth. And one of the main arguments was that if the Earth was moving, everyone would literally fly off the Earth because it would be moving so fast. Now, it turns out that the Earth is revolving around the sun, but what people didn't understand is that motion is relative, and when something is moving, you don't feel that motion, first of all, and that you have to have a point of reference that motion is relative to. So because you're on Earth and Earth is moving, you don't feel the apparent motion because you're moving with the Earth. Let's say you're on the Earth driving a car. That means everything in your car relative to you is not moving, and the stuff outside the car is moving. But to someone outside, you are moving relative to them. The first principle for understanding speed is to have a point of reference. If you don't have a point of reference, all motion becomes confused, and you can't really discern what motion is if you don't have a point of reference. This is the part of the book where it explains three main concepts for speed. It's speed, first of all, velocity, the second one, and acceleration. And each of them build off of each other. So I'm going to start with the simplest one and then go up to acceleration. So speed is a measure of the average speed between point A and point B, or distance divided by time gives you the average speed. So if I'm going from my house to a city, it takes me 2 hours and it's 120 miles away, that means I'm moving 60 miles per hour on average. But that doesn't mean I'm always moving 60 miles per hour, because maybe there's stoplights. Maybe to drive out of my house, I'm not going to be moving 60 miles per hour in my neighborhood. Speed was the most basic grasp of motion, but then we get on to velocity. Velocity is speed with a direction. So it's getting more specific. Let's say 50 miles per hour north or east or west or south. That's what velocity would be. Velocity would be speed with a direction, and you're specifying the direction. Now finally, acceleration. Acceleration is a change in velocity. So what that means is that take your final velocity, subtract that by your initial velocity, and then you take how much time it took to do that. So if you went from 20 miles per hour to 50 miles per hour in 3 seconds, you say 50 miles per hour minus 20 miles per hour divided by 3 seconds gives you an average rate of 10 miles per hour per second. What is so exciting about acceleration that some people don't fully get is that acceleration is based on velocity and not speed, which means that velocity is a speed with a direction. So if your speed stays constant and your direction changes, you are still changing in velocity, because that's what velocity is. It's speed with direction. A car that is constantly gaining speed in a certain direction is accelerating, okay? And a car that has a constant speed but is turning is also accelerating, because acceleration has to do with velocity. Now, what was velocity? How to define velocity? Velocity is the speed of something with its direction. The speed something falls will increase by 10 meters per second every single second. That's like a very simplified version of it. It's actually like 9.8, but this book rounds to 10 just for simplicity's sake. So after 1 second, it's traveling at a speed of 10 meters per second. After 30 seconds, it's 30 meters per second, and so on and so forth. So the distance that something travels in relationship to time can be expressed as 1/2 gt squared. 1/2 is the average between multiple points. 1/2 is like the average for the average speed something is moving. That's times time squared. Now, there is definitely a footnote in Conceptual Physics that will derive this equation, but what it's saying is every single time something increases by 1 second, it will increase its distance exponentially. So 1/2 gt can be simplified as 1/2 times 10 times time squared, which means that 1/2 times 10 is 5 times the time squared, meaning after 1 second, the average speed of something from 0 seconds to 10 seconds, the average of 10 meters is 5 meters. So it would be traveling 5 meters. But let's say something is traveling for 2 seconds. It's traveling from 0 to 20. Then that means it's that means it's 2 squared times 5, which is 20 meters. Because the first second it travels 5 meters, the second it travels 15, and so on and so forth. And after 3 seconds, it travels 45 meters. And there's one last point that the chapter 2 makes, and that's about terminal velocity and air resistance. In space, something would continuously accelerate in a gravitational field if there wasn't air there to slow it down. Luckily for Earth, there is a terminal velocity, so it will eventually stop accelerating. But on places like the moon, it would constantly accelerate towards the moon if it was dropped. And then another thing is, when you think about air resistance, gravity pulls, and the book gets into this later on in the book. Gravity pulls equally on all objects, and when there's no air resistance, stuff like a hammer and a feather will fall at constant rates. So what this means basically is, when there's no air resistance, something gets pulled, 2 things will get pulled the same amount. 2 things will be pulled the same amount, and they will fall at the same speed on the moon.